Okay, hello, good afternoon, good morning, good evening, wherever you're calling in from. Thank you so much for joining us today. We are here with Alex Yanishevsky, our Senior Director of AI and MT Solutions here at Smartling, and he is going to talk about how to launch new languages with AI. Alex, thanks for joining us.
Hi, thank you very much for having me.
All right, why don't we just go ahead and dive in?
Great. We're starting with a poll or not yet?
Oh yeah, let's launch the poll. Let's go ahead and launch the poll first. So before we kick things off today, we just wanted to open the poll to see what are your drivers for launching a new language, and this will just help us get a better idea of everybody's goals. So oftentimes you might be launching a new language to break into a new market based on demand of where your customers are. Perhaps you're testing a new market. Maybe you're doing something to match what your competitors are doing. Perhaps it's an existing market, but a new language. And if none of the above fit your use case, go ahead and drop in the chat. We'd love to hear why you add new languages. So go ahead and weigh in on the poll. And yeah, like I said, if something doesn't fit, feel free to drop in the chat. We are curious to hear that as well. All right, I'm going to go ahead and close the poll. So Alex, what do you make of these results?
Great. So yeah, so it was kind of what I was expecting that a lot of it would be breaking into a new market as a way to gain additional revenue, or or adding a new language to an existing market, right? Where also in an opportunity to expand this market. And this will kind of help me as well as I navigate the discussion here and kind of try to walk a fine line between not being super technical, not being super business, and kind of try to walk a balancing act between the two. So as far as our agenda, right, you could see the title is how to launch new languages with AI. So I kind of wanted to get started with just terminology, right? Something that we can all agree to, at least kind of to explain from our perspective how we see AI and what it is that we're talking about there, right? From there, I wanted to talk about different content types. And once we figured out, okay, what in AI are we using to do this translation? What content types are suitable for this? Perhaps some are not, to try to give you our recommendation. And from there, that kind of follows into the next logical point, which is, okay, we have these different content types. Should we have a human in the loop for all of them? Right? Perhaps for some we shouldn't. Perhaps in some cases a human should be a language co-pilot, but perhaps there's some content types, because of their shelf life, because of their audience, where we may not need a human in the loop. Right? Then ultimately, in order to roll out new languages, we're going to talk about what choices we have with machine translation engines. Should we be using generic engines? Should we be using customized engines? And should we be using LLMs? And kind of some best practices that we've seen from our research team. Then kind of the practical implementation. Okay, great. Well, what languages are out there? How do we divvy up these languages? Because we're probably not going to launch into 40 languages all at once, or add 40 languages all at once. How can we be thoughtful and mindful and strategic about the languages that we add, and what sort of rollout plans tend to work very well? And then lastly, some ideas for success criteria. What is it that we're trying to get out of this to measure our ROI, and how do we continue monitoring and do further maintenance? And I'd also encourage you, as we're walking through this, please feel free to put questions in the chat, and we'll do best to address them either during this webinar. If we don't get time to do so, we'll follow up and provide our thoughts. So as far as AI, this is kind of our view of the world to differentiate between AI and LLMs and neural networks and machine learning. I think the thing is, we see a lot, especially in media, that AI and LLMs are used as synonyms, right? You generally kind of hear people saying, hey, let's just AI everything, right? As though this kind of magic genie comes out, fixes everything, and then we're all done, right? That's if that were only true, unfortunately, it's not. It's a lot more complicated than that, right? So I like to think of this as kind of concentric circles, right? So think of AI as basically anything that involves a machine that can perform tasks that are characteristics of human intelligence, right? That's kind of the bigger umbrella. Now, within that, there are a bunch of different algorithms that allow a machine to get to that state of performing these tasks, right? So the first one of these concentric circles is machine learning, right? And the idea is the ability to learn without being explicitly programmed. And what I mean by that is this is not necessarily deep learning, right? If you think, for example, of something like Zillow, where you try to predict the prices of your house based on similar houses in the neighborhood, right? You could be using algorithms that don't necessarily require large language models, right? And they're going to do perfectly well and be perfectly reliable, right? So there are in fact some algorithms that work where we don't need large language models. Now, for the purposes of our discussion, which is translation, we are going to be talking about deep learning, right? So the next kind of concentric circle is neural networks, right? So I'm sure most of you have played around with or have heard of things like Google Translate, Microsoft Bing, right? Amazon Translate, etc. A lot of these are based on neural machine translation technology. The acronym is NMT, and this does use deep learning. And the idea of neural networks is, okay, this is kind of loosely based on how the human brain works, right? Like the way neurons in our mind work, right? Now, what we've seen in the last 3-4 years, and obviously GPT is what made this really popular, is large language models. And here we're talking about, and this is kind of the innermost circle, this is very, very deep learning with billions of parameters, right? When we were talking about chat GPT, like 175 billion, there's some models now that are 540 billion, right? So really, for us, fundamentally, what we're going to be talking about are the two concentric circles of neural networks and large language models, right? So how can we use these two, right? I'm not going to go into like all of the math behind it, but how can we use these two in order to accomplish our machine translation tasks as effectively as possible and roll out existing languages, right? So that's why I wanted to give you kind of a framework that we begin with. So, when we talk about content types and humans in the loop, right? The way we kind of see this is as three distinct buckets, right? Going from the left to the right. If you look at the left and you think of just machine translation, again, we'll get to the question in a moment whether we do it through neural networks or LLMs, but just the act of pure machine translation, which happens very, very quickly. The quality is very, very good, right? There's no human in the loop here, no language copilot, right? And this typically is content that has a lower emotional engagement, right? So I'm thinking of things like support tickets, forums, customer reviews, knowledge bases, training materials, right? Where if you don't get the correct synonym, it's perfectly okay because it just needs to be actionable, right? Now, as we go further to the right, we have MT plus a human in the loop, right? And so basically the idea here is that the human being is the language co-pilot. There's a lot of stuff that we can do, especially in our platform with AI, that'll make the human being very, very productive. But ultimately, you're going to need a human being who knows your style guide, right? And who's going to be able to bring this up to a human quality. And here we're talking about things like product manuals, things like low touch marketing, things like blogs, commercial contracts, right? E-learning materials. And then really the last thing here is where you want a human in the loop, and probably neural machine translation won't help you. Maybe possibly an LLM will help you, but you basically need very, very high touch, because this is high touch marketing, very specialized translation where you need a very higher emotional engagement, right? So the whole point of all of this is, as you're thinking about new languages, right? If you think about your content types, probably, and you can, if this matches roughly the diagram that we have here, the biggest takeaway from this is machine translation as a first step is imminently usable for the vast majority of content, right? And in the middle step, when it's coupled together with AI processes, you can get to a human quality very, very quickly. So this kind of takes us to the next step of, all right, let's say we've decided what are content types, in what categories they go into. What sort of machine translation do we use, right? That first step before the linguistic copilot, before the human being, what do we do? Right. And again, I think this is a nice way to represent it with three different buckets of good, better, best. Right. So good is essentially, especially in the Smartling platform, we have this idea of auto select where we can use a generic engine. So think of your Google Translate, think of your Amazon, think of your Microsoft, but rather than you doing bake-offs and saying, hey, what's the best one to use for Spanish or what's the best one to use for German? We have a machine learning quality assessment where we're able to choose the best one per language pair. Now, when I say generic engine, what I mean by this is your Google Translate without anything else on top of it, right? Now, the better bucket is the same thing, but now we're overlaying your client specific glossary. So for example, think of the word check, where if I'm a financial company, check as a financial instrument is very different than the word check in your common parlance, where I would say, hey, check to make sure that the lights are on, right? So this begins to give you more relevant output. And really, the best output is if you're able to train or customize an engine with all of your assets, meaning your translation memories, your glossaries, your do not translate lists, right? This is the best at representing the brand. A couple of kind of call outs here to mention. Even though a lot of times we talk about English as being the source language, or secondarily, English as being the language that we go into, let's say from German into English or French into English, the current generic models are already multilingual. So you actually don't need to have English as a pivot. So we have clients, for example, who need to go from French into Spanish, from German into Spanish. And what's nice is, because these models are multilingual, we don't need to use English as this intermediary hop. They're already quite good at going from French into Spanish without English, right? And the looming question then is, okay, great. So if you remember these concentric circles, right? Cool. We have neural machine translation, but we also have LLMs, right? So I think probably a lot of you are saying, well, can't we use large language models for this? You know, we have GPT-4, we have GPT-4 Turbo, we've got Google Palm, Anthropic, etc. Can't we use that for machine translation, right? And I'm going to show you in a couple of slides kind of our take on it, where we see large language models performing best, and it's not necessarily machine translation. I won't fully give you the answer just yet, but just something to consider, right? And just one other point as we're talking about customizing engines, right? A lot of this has to do with a couple of factors. One factor is, in order to customize engines, you need data, and that data needs to be reliable, right? So to customize, let's say on top of a Google or Microsoft, you need at least 10,000 sentences. Now, for some clients who are getting started, they may not have that data. So that's really addressed in what's called a sparse data scenario, meaning you don't have enough data, you've got less than 10,000, right? The way that's addressed is by Google Adaptive Translation, which is basically a large language model specifically made for translation tasks, right? So that's a good way to get started. And then once we get beyond that 10,000, we can start doing benchmarks between Google Adaptive and the neural machine translation technology, right? So I kind of, left open that question and said, well, what about large language models? Should we use them for machine translation? Right. So what you see here is I've highlighted in green. This is from our R&D group, where we compared neural machine translation models to large language models, to like GPT, to Google Palm, GPT-4, and what we're seeing is that the current generation of neural machine translation models is still outperforming LLMs purely for translation tasks. right? So that's why you have this note here that says, well, for machine translation, we wouldn't recommend using LLMs just yet, which kind of begs the question, well, okay, so what do we do now? What are these LLMs good for, right? And what we find that they're amazingly good for, right? And this is kind of like this walking this last mile of making the machine translation very, very very productive is doing automated post editing or correcting machine translation, right? So basically, you have something like a customized engine that gives you the first pass, and then you've got all of these routines with a large language model, right, with prompts that can actually make that output even better, more relevant. Therefore, the linguist could be more effective, can do things more faster, cheaper, right? So that's the idea behind it. Right, so we just wanted to show you a couple of these techniques. And right, so where do we use LLMs? We use them for things like repairing your translation memory. I'll show you an example of this. Inserting the glossary in a way that's grammatically correct, or estimating the effort, actually telling a linguist, hey, look, you've got machine translation. What do we think your effort will be? Will you be able to do this quickly, or will this require a lot of work? And a couple of things that we're working on that's going to be coming very soon is being able to actually use your style guide to start switching formality, right? The machine translation engine gives us something, and here's where we use a large language model and say, well, hold on. The client told us this needs to be informal. Great. Let's change that and make it more suitable, right? Things like gender debiasing, right? If we need to change our copy so it's not so masculine oriented, we can do that as well with large language models. Right? So a couple of examples of really, really useful things that we can do with large language models. I talked about fuzzy match repair, which is, right, you've got your translation memory. It's your database of things you've translated before. So here we have a new text that comes in. You can see the word chat, but in our translation memory, we have photo, right? Now, we can actually send a prompt to the large language model and say, hey, look, you've got a sentence that's pretty similar. Let me give you an example of how we would translate it. And then the large language model can actually generalize from this and go, oh, okay, so you want roughly the same sentence, but we just need to change photo to chat, and this is what we do. But the part that's really important is not just blindly changing photo to chat, it's actually changing the modifier before it as well to be grammatically correct, right? So that's that whole ideal process of machine translation through neural technology and LLM, and now the human being gets something that takes them much, much further, so they have much less to edit, right? And we can do a similar thing with a glossary insertion, right? Where here's our text, here's our translation, but we can actually do a lookup and say, hey, wait a second, post should not be translated as post, it should be translated as publicación. And with a large language model, we can actually make this correction and also note that, wait a second, this became a feminine noun. Well, the adjective before it, the modifier, needs to be feminine too. So large language models are extremely, extremely useful at doing that, right? Then finally, last thing is edit effort estimation. So after we get our machine translation, right, with all of these things that we just changed that I was showing you, we can actually get a large language model that'll give us a prediction and say, hey, there's very little to edit here. And maybe we even publish this straight out, or there's a low edit required. So maybe we have one person this versus, let's say, level 3, which there could be a critical error and we might need a couple of people to look at this. So as we talk about rolling out languages or rolling out new languages, right, some other things to keep in mind, which is this language complexity table. Obviously, because we have only so much screen real estate, we can't fit everything in here, right? But hopefully this will give you an idea of where languages lie. And what we're trying to accomplish here is to show that some languages grammatically are A, easier, and B, we just have more data out there, right? So for example, Romance languages will tend to do quite well. Germanic and Slavic languages would tend to be in the middle, and Asian languages, bidirectional languages, will tend to be very, very high complexity, and for some of them, there isn't even as much data. right? So, and then here you have under-resourced or low-resourced long-tail languages for which we really don't have that much data, right? So one of the things to think about when you get started is using this language complexity matrix, right? This is a good way to get started and a good way to add additional languages. So one of the things that we'd recommend, right, is you can do things like you can do this is kind of going back to the idea, right? How do you use these languages and how do you roll them out? You could roll them out. What's the technology? You could roll them out with auto select with a glossary insertion from LLM. You could use Google Adaptive, right? Or you could use customized engines. So the reason I was showing you this low, medium, high complexity is one way to think about this is this is what we recommend to clients is choose a language that represents one of these groups, right? So for example, choose something like Spanish or Portuguese or French or Italian, which is a low complexity language. Choose German, Ukrainian, Polish, which is a medium complexity language. And let's say Japanese, Chinese, Korean, which is a high complexity language. And the idea is when you benchmark a language from that group, it'll give you a sense of how other similar languages will perform. They're not going to be verbatim one for one, but generally speaking, Portuguese and Spanish are going to run together. Like Portuguese is not going to do as poorly as, let's say, Japanese. It'll do as well as Spanish, right? The same thing, Korean will generally not do as well as Spanish. It'll do as well as Japanese or Chinese, right? So the idea is that this allows you to really manage your expectations, right? So that's really a really good way to get started, and also a good way to continue adding additional languages, right? So now you might think to yourself, okay, well, how do I add more languages if they're low resource languages, right? And here, something that I wanted to show you, when we're saying low resource languages, we mean languages, some companies call them tier 1, tier 2, tier 3, right? And tier 3 would be languages that are long tail or low resource languages. I give you some examples here, for example, Yiddish, Lao, and Amharic. And again, we see a similar thing that I was showing you with the more common tier 1, tier 2 languages, which is, again, large language models don't do as well as the current neural machine translation engines like Microsoft or Google, right? Also, there just isn't a lot of data for these languages, so they don't perform as well. So how do you solve this problem, right? This is like a pretty difficult thing for data scientists and computational linguists to do. It's not to say that we can't use these languages. We can. And one of the ways we do so is we synthetically create data, right? It's called data augmentation. There's a technique where you could basically take sentences for which you have translations, and you could generate similar sentences to those sentences, right? As a way to generate more data. So just kind of like a rough example, say I have the translation for something like, I go to work on Monday. You could generate additional sentences like I go to work on Tuesday, Wednesday, etc. Or, I go to lunch on Monday, Tuesday, etc. Right? So that's a way of kind of trying to get more data so you could go ahead and train an engine. So as far as success criteria, I think this is going to be the same whether you have existing languages or you have new languages, right? It's going to be, you're going to want to be using machine translation and other AI underpinnings that I was showing for lower cost, for a faster time to market. And the crucial thing is you want to do this while retaining the same quality or even better quality, right? And that's kind of the promise of all of these AI underpinnings, that it allows us to do all of these three things at once and kind of have your proverbial cake and eat it too. Right. So just to show you a couple of ways we ourselves accomplish this in the platform, right? So when we're using Smartling language services, right, we're ultimately able to get to this 98 plus MQM score. And the reason we're able to do so is with some of the things that I was showing you. So things like fuzzy match repair, things like machine translation, but in our case, we can actually, when we're doing this internally, we query 4, sometimes even 5 different engines on a sentence level and choose the best one the best MT provider for that sentence, and then do things like glossary insertion and effort estimation. Right? The other thing, and you'll see this mentioned very, very soon, an announcement coming on this is our AI translation toolkit. Again, this goes to the idea that I was showing you about rolling out new languages where you've got AI and neural machine translation technology working together, right? So we're still getting our machine translation from the same Google or a customized engine, but we're doing a lot of AI through large language models, right? So things like glossary insertions, things like edit effort estimation, and fuzzy match repair in order to improve what the linguist will get and allow them to work faster. And we've seen actually very, very good results from that. So quite a significant reduction in linguist time, decrease in number of edits while keeping the same MQM score, right? So one last thing I want to say is when you roll out a new engine, a new language, you're not done, right? It's basically now you need to think about maintenance. It's not like you've done it and okay, you go off and don't do anything for the next couple of years. You want to continue to update and optimize your glossary. You want to continue to update and optimize your TM because these are the building blocks for creating a machine translation engine and for basically making sure that that engine stays relevant. And what's nice is in the platform, we've got tools that allow you to do this in a fairly automated way. And you want to have a cadence where you're retraining these engines to prevent content drift, right? Obviously, your content, you're going to develop new features, your content is going to move. You want to make sure that these engines are moving along with the content. So last slide here, which is the takeaways for this. So hopefully you'll see that most content types from an enterprise are suitable for an MT-enabled workflow, right? Customized MT engines will provide a better quality and provide a lower cost. We suggest to start with a pilot, right? So if you're going and rolling out new languages, think of different, as I showed you, different levels of complexity, different groupings as a way to roll out languages, roll out new languages. And then again, the takeaway being that LLMs do a very, very good job, ironically, at non-MT tasks, at post-editing, at things like fuzzy match repair, edit effort estimation, and glossary insertion. And lastly, I've shown you a couple of examples. I mean, we're an AI-enabled platform, right? So if you use our language services or if you're using the AI translation toolkit, what you're getting is a lot of these AI underpinnings that are going to provide dramatic cost savings and time reductions and really begin to bridge that last mile that the linguist needs to walk.
Okay, great. Thank you so much. We have a few questions, so we have time to get to some of them. Alex, before we move away from the AI translation toolkit too much, Patrick did ask a question about the metrics that you shared, and if you could share a little more details around the tests that we ran and kind of how we came to these results.
Yeah, sure. So we have, I'll try to group them very, very quickly because we actually have about 10 different scores. If I go through all of them, it'll take a really long time. But to try to sum it up, we have both automatic textual scores and we have automatic semantic scores. By textual scores, what I mean are things like your usual suspects like BLEU, Meteor, edit rate, let's see, Comet, right? And then semantic scores like Comet, Laser, LabZ, Blueword, right? So what we're trying to do is basically manage by exceptions, right? We're looking to see if the textual scores for BLEU are higher for NMT engines versus LLMs. That's kind of how we made that. We made that decision, right? And then we also want to see that that's bolstered by semantic scores, right? That we see the same correlation both for pure mathematical calculations and semantic calculations, right? And when we talk about, like, when we're saying actionable, one of the scores that we measure is this idea of human or near human parity, which is essentially saying if the number of edits I need to make is 10% or lower, we would consider that to be a high fuzzy match or above, and that's basically on the level of human parity, right? So if you think of a high fuzzy match, by and large, those are actionable. So that's kind of one of the ways also we look at it. I hope that answered your question. If you have more follow-up, please drop it into the chat.
Yeah, he also asked a question that kind of piggybacks on your answer about neural machine translation. So, is neural machine translation accurate enough for actionable translation? And have we seen performance above 85% in the highest performing languages?
Yes. So yes to both. Yes, we find it actionable enough, for sure, for manuals for help, right? And as far as 85% and above for the Romance languages, yes, that's the case. Caveats being, we're talking about customized engines, right? Not generic engines. I would put generic engines for Romance languages probably like in the mid 70s, and with a customized engine, we're typically seeing at least 10-15% increase over generic, and sometimes even as high as 35%. I would put that then into the mid 80s. And again, defining actionable in the way that I just did right now, where a customized engine may not get exactly the correct synonym, but you're going to be very much in the right ballpark and you'll know what to do in a way that's correct.
Great, thank you. We have another question around Google Adaptive Translation. So Adriano asks, I don't quite understand how the Google Adaptive Translation would increase the number of sentences. How would that work for underrepresented languages, for instance? I'm worried that it would further increase the divide between colonial languages and all of the other ones.
So Google Adaptive is quite new. We actually were at Google Next with Google co-presenting on this. Our findings a couple of weeks ago. Google Adaptive currently supports only 6 languages, and it doesn't really cover low resource languages at all. It doesn't cover indigenous languages at all. So Google Adaptive, at least as it stands today when we speak, covers basically Chinese, Japanese, Romance languages, and it's really good for that situation where you don't have enough to customize an engine. If we're talking about long tail, low resource languages, like some of the ones that I was showing, right, like Amharic, for example, like like Pashto, really the best thing that you could do is be using generic engines. And for some of those low resource languages, like let's say a Hungarian, you can customize. We've actually customized for clients before, but it really requires then 10,000 translation units or more. I mean, we could do some things to get there by synthetic data augmentation, but it's still something that's difficult to do. Like it's not going to perform as it will perform, and you'll get productivity. It's just not going to be as crazy good productivity as you'd see for Romance languages.
Cool. Thank you so much, and thank you everyone for asking questions. We have one more here for you, Alex. What advancements in LLMs are researchers working on that may affect localization?
So one like future state thing that we're working on is, so some of you may know, for example, GPT-4 from OpenAI is multimodal, which means that not only can it read text, it can actually ingest images as well, right? So one of the things that our R&D group has been working on is, can we actually get a better translation by doing a multimodal translation, right? And what I mean by that is, imagine you have, right, a palm, right, the palm of my hand, right? That's very different from a palm tree, right, that grows in warm climates. So imagine I was translating a manual that had, like a medical manual, right, that had a procedure that had to do with my hand. If I can actually tell an LLM, here is the picture of my palm and the text for the word palm, right, it would more likely be correct in translating the word palm as, right, my anatomical hand rather than a palm tree in a warm climate. right? So the idea is, hey, can we now send um, additional information to a large language model other than text? Can we send it images, and that will help it give a more contextually correct translation? This is like a little bit off, but it's a really cool area of research.
All right, great. Well, that is all that we have time for today. So thank you so much. And thank you to everybody who joined us today. And we hope that we'll see you again on May 8th for our Global Ready conference. We are announcing that Minette Norman is going to be our guest keynote speaker. She's preparing an excellent talk about how to future-proof your career in the age of AI. So I hope that you don't miss it. I just dropped in the chat a link to the agenda and the registration page. So have a look at all the sessions that we have planned, and we hope to see you there. And thank you again, Alex, for sharing with us today. It was a great presentation. And as always, you can reach out to us at hi@smartling.com or reply to any marketing email if you have any questions. So look forward to seeing you again soon.